I'm going to talk today about a translational approach to targeting the KEAP1 NRF2 signaling pathway to potentially attenuate exogenous stresses, particularly derived from carcinogens in air pollutants. But let me start with a quick broader overview that it's very clear that NRF2 is an important susceptibility or resistance determinant in many different diseases. This comes very clearly from a variety of different animal models where typically NRF2 disruption sensitizes animals to these different pathological outcomes. Pharmacological interventions with activators of NRF2 signaling are in many cases protective in these settings, and in a few instances, overexpression of NRF2 in a genetic sense has also been shown to be protective. Our major interest is in pharmacological approaches to upregulating NRF2 signaling. We've taken a variety of different small molecule approaches. Today I'm going to talk about the natural product sulforaphane and isothiocyanate found in reasonable abundance in cruciferous vegetables such as broccoli. Our overarching interest has been in addressing the question, can people be protected from unavoidable exposures to environmental carcinogens through targeting NRF2 signaling? And we hope this has broad relevance to dealing with exposures to airborne, foodborne, as well as waterborne pollutants within our environment that contribute to our disease burdens, including cancer. Air pollution is a very important public health problem. This slide indicates that over 80% of the world's population breathes polluted air that exceeds the World Health Organization's recommended levels of exposure. Particularly notable is Eastern China, but I'll also point out that London and other aspects of the UK, as well as parts of the US, have major excursions into unacceptable levels as well. What can people do to attenuate their risks? This shows a satellite picture of Eastern China, which again amplifies levels of pollutions. We've been doing studies in Eastern China and Qidong, just north of Shanghai, where air pollution is also at unacceptable levels. Very briefly, we recognize that sulforaphane, again derived from cruciferous vegetables, is a very effective activator of NRF2 signaling, interacting with the target cysteine, cis-151, in the repressor protein KEAP1. This blocks the Col3 ubiquitin ligase activity of KEAP1, blocks the marking and thus the signaling of NRF2 for proteasomal degradation. This allows new NRF2 to translocate into the nucleus, where it leads to the induction of glutathione biosynthesis, increased expression of glutathione transferases, and many other genes involved in the NRF2 program. But important to detoxification of air pollutants is the enhanced capacity to conjugate these molecules with glutathione, leading to their excretion as detoxification products, mercapturic acids in urine. So this pathway prompted us to conduct a randomized clinical trial of a broccoli sprout beverage rich in sulforaphane in the Qidong region of China. We had approximately equal numbers of participants enrolled to receive a placebo beverage nightly for 84 consecutive days, or a sulforaphane-rich broccoli sprout-derived beverage. We collected urine samples at biweekly intervals throughout this 12-week period and periodic blood samples as well, to assess biomarkers of the potential efficacy of the intervention. We wanted to address two questions. The first is this intervention efficacious? Can we alter the disposition of these air pollutants in people as a function of randomization to broccoli sprouts? And is it sustainable? Can we keep triggering this NRF2 pathway to successfully alter the fate, increase the detoxification of airborne pollutants and carcinogens? This trial was done as a synchronous trial, so all participants enrolled at the same time and progressed through the trial at the same time. This was important because the uncontrolled variable in this study was the ambient air quality or air pollution. This came from a very geographically defined area, so people were breathing the same pool of air, if you will. Overall compliance in the study was exceptional. 92% of the participants completed the trial, and most all of them drank every single beverage and provided every single biospecimen to the study. We collected lots and lots of urine, which is the substrate for our biomarker analyses, and we used this, again, to measure the detoxification products of several airborne pollutants. Air quality during this 3-month period was not very good in this region, as shown by these measures of the air quality index of PM10. shown both for Qidong itself, a rural area northeast of Shanghai, as well as measured in the urban center of Shanghai itself. And just as a point of comparison, today's measure in Cambridge, England, shows very high quality of air, which is far different from what was being inhaled by the participants in this study. When we look at benzene, a known human carcinogen, we find that there's a very rapid and sustained increase in the excretion of the detoxication mercapturic acid. So it appears that we can rapidly activate the NRF2 signaling pathway and that it is sustainable with the repeated nightly doses of the sulforaphane-rich broccoli sprout in comparison to the placebo beverage. Overall, we saw a greater than 60% increase in the rate of elimination of benzene as this detoxication metabolite. We looked at several aldehyde components of air pollution as well, and with acrolein, a strong irritant but not a carcinogen, we again see a rapid and sustained increase, smaller magnitude, about 24% increase, but consistent throughout all the time periods. And interestingly, with crotonaldehyde, another irritant aldehyde, we saw no effect of the intervention. So this approach targets some pollutants, but not all pollutants. Why? Well, we now recognize that different isoforms of glutathione transferases are important for the detoxification of these different pollutant substrates. Glutathione theta 1 and M1 for benzene, GST-P1 appears to be very important for acrolein, and there are not any identified GST isoforms that enzymatically catalyze the conjugation of crotonaldehyde. So perhaps these differences in isoform requirements for these different substrates in turn define the different responses to the broccoli sprout beverages. At this point, though, it's not clear that this is a direct NRF2-mediated pathway. We're simply inferring from known mechanism of action of sulforaphane that these changes in mercapturic acid excretion are indeed directly NRF2 dependent, and future studies will need to burrow more deeply into addressing that question. So let me conclude by saying keep calm, drink your broccoli, and perhaps there are safe and effective approaches where individuals can be empowered to reduce their burden of unavoidable exposures to environmental chemicals.